Hello students, keep ready the notebook and the pen. Then when we start discussion, you start making the notes of important points. Whenever you do so, the material that you have prepared out of the discussion will be the best material, because that you will be writing on your own by your interest, so that you can understand very easily than whatever material that we give. So try to develop the habit of making notes on your own. Clear students? Okay, let's start. We have seen in the past video meaning of solution and their different ways of expressing the strength of the solution. Based on that, we have some problems in the textbook. Let us try to solve them. Okay, let's go for first problem. That is 2.1 problem, which is on page number 37. What it says is, calculate the mass percentage of benzene. Calculate the mass percentage of benzene C6H6 and carbon tetrachloride CCl4, carbon tetrachloride, if 22 gram of benzene is dissolved in 122 gram of CCl4. Okay, let's see students. So what is given is mass of benzene and mass of carbon tetrachloride are given, and they are asking us to calculate mass percentage of benzene and CCl4. Students, we know that mass percentage is weight of solute divided by weight of solution into 100. Here weight of solution is nothing but weight of solute plus weight of solvent. Clear students? Okay. Now, let's go for calculation of mass percentage of C6H6. Okay. This is equal to, what is this? Weight of the solute. How much to take? Weight of solute is weight of benzene. How much it is given? 22 gram. That means 22 gram of benzene divided by solute is same, 22 gram, plus weight of solvent. How much it is? Weight of solvent 122 gram. That means 122 gram. Here 22 gram divided by, what is this? 1, 2, 4, 4. 44 gram. Gram get cancelled, so you get 1 ratio. And this ratio is, see students here, this will be 22 divided by 144. This is, how much it is? This is 0.1527 is that. 1527, we can make it as 0.1527. Instead of 27, I can make it as 3. This is mass percentage of benzene in CCl4. Similarly, mass percentage of C6, not C6, mass percentage of CCl4, mass percentage is C6. Now we'll have to take weight of CCl4. Weight of CCl4 divided by weight of CCl4 plus weight of C6H6 into 100. See students, we have forgot here. We will have to make it as into 100. It means it will be into 100. It means it will be 15.3%. Mass percentage is that much. Calculate the mass percentage. That means it is 15.3. Yes students. Now, this, with respect to this, what is the weight of CCl4? Which is 122. 122 divided by, so total mass we have got as 144 into 100. So this will be 122 divided by 144. This is 0.8472 is that. Let's do this. So we can make it as 7 only. And into 100. This will be 84.7%. Is it clear, students? Now, these are the mass percentages of individual substances. To check whether these values are correct, then you have to just add these two. If you add these two, you should get exactly 100 or nearby 100. See, students, 15.3 and 84.7. This will be, if you add these two, then it will be 0. It will be 0. It will be 10. So it is 100%. It means that whatever answer we have got, it is correct. Clear, students? See, sum of the mass percentages is also 100. Clear, students? Now, suppose if it is not 100, it is just mass ratio. If it is not mass percentage, if it were just mass ratio, then look at this. Only this would have been the answer. Now you check, you add these two. That is 0.153 plus 0.847. It will be here 10, 10, 0 and 1. See, students, here. If it were percentage, in terms of percentage, it will be 100. If it is not in terms of percentage, it is even just in terms of say number, just mass ratio, then the sum of the mass ratios of all the components will be also equal to 1. It will be 1 if it is in just in terms of ratio, and it will be 100 if it is in terms of percentage. Clear, students? So sum of the ratios of mass is 1 and sum of the mass percentages is 100. Clear? Okay, let's go for next problem. Next problem is calculate the mole fraction of benzene solution. That is 2.2. Calculate the mole fraction of C6H6 benzene solution. Calculate the mole fraction of benzene solution containing 30% by mass of CCl4 solution. Containing 30% by mass in CCl4 solution. Okay, students, here mole fraction is asked. Mole fraction is asked, but mass percentage is given. Clear, students? Here mole fraction is equal to, say, mole fraction of C6H6 is equal to number of mole of C6H6 divided by number of mole of C6H6 plus number of mole of CCl4. This is required. This is required. Okay. Now, to know the number of mole, we need weight, isn't it, students? To know the number of mole, we need weight. So weight can be calculated as weight is equal to, what is this? How will you calculate weight? See, they have given mass percentage. Weight by weight percentage they have given. So weight by weight percentage is equal to, what is this? Weight of solute by weight of solution into 100. Okay. It means that this implies, see, 30% weight by weight percent implies that 30 gram of C6H6 is dissolved in how much? 100 minus 30, which is equal to 70 gram of CCl4. Remember this, students. 30% mass by mass of benzene stands for 30 gram of benzene is dissolved in 70 gram of benzene, so that total volume of the solution or total weight of the solution will be 100. Is it clear? So C6H6 as 30 gram and weight of CCl4 as how much? 70 gram. Now out of this, what you have to do? You have to find out, see here, you need to calculate mole fraction. So you have to find out number of moles. And we know that number of mole is equal to weight divided by molecular weight. Is it clear, students? Weight divided by molecular weight. Okay. Now let's go for number of mole of benzene, C6H6, which is equal to, weight is how much? 30. 30 divided by benzene molecular weight. See here, C6H6, which is C is 12, atomic mass of carbon is 12 into 6, plus atomic mass of hydrogen is 1 into 6. It will be 72 plus 6, which is equal to 78. Similarly, mass of CCl4 is equal to, atomic mass of carbon is 12 into 1, plus atomic mass of chlorine is 35.5 into how much? 4. This will be, see students, this is 12 plus 20, 22, then 14. So it will be 142. So total will be, say, 142 plus 12. This is 4, 5 and 1. So 154. See students, 142 plus 12. This is 154. So molecular mass of CCl4 is 154 and that of benzene is 78. Okay. Now number of mole of benzene is equal to 30 divided by 78 and the number of mole of CCl4 which is equal to 70 divided by 154. Okay. This will be 30 divided by 78. This is 0.38. 3846 is there. 3846. We can take it as 0.385. And this is equal to 70 divided by 154, which is 0.45. It is like 0.454545. That means we can take it as 0.3 digits after 454. Okay, these are number of moles. Now what we can do? Now we can calculate mole fraction of benzene, C6H6, which is equal to number of mole of benzene divided by number of mole of benzene plus number of mole of CCl4. This is equal to number of mole of benzene is 0.385 divided by 0.385 plus 0.454. This is equal to 0.385 divided by this one. How much it is? Say 9, then 13, then 8. 0.839. Check here. That is 4 plus 5, 9. 5 plus 8, 13. 1, 5 plus 3 is 8. Okay. And this will be 0.385 divided by 0.839. This is equal to 0.4588 is there. 0.4588 is there. We can make it as 0.459. This is the mole fraction of, what is it? Benzene. This is mole fraction of benzene. Then see, we can, it's not necessary, but we can calculate mole fraction of CCl4 as 1 minus mole fraction of C6H6, which is equal to 1 minus 0.459. This is equal to 0.5411. It is not necessary, but to check whether it is correct, if you add these two, how much you should get? 1. Sum of the mole fraction is always equal to 1. So 0.459 plus 0.541. So if you add this, it is 0, it is 0, it is also 0, so 1. So it is correct. Clear, students? Okay. Let's take another example. The next example is which is 2.3 of the exercise part. Calculate the molarity of each of the following solutions. Calculate the molarity of each of the following. Say first one. What it says is 30 gram of CONO3 twice 6H2O. So hexahydrate cobalt nitrate or hydrated cobalt nitrate is in 4.3 liter solution. This is first one. Second one is 30 ml of 0.5 m H2SO4 is diluted to 500 ml. So in these two cases, you have to find out the molarity. Okay, so let's go for first one. First one, A. See, molarity. It's not molarity. It is molarity. It's not M. It is capital M. Molarity. It is not this small m. It is molarity. You know the difference, isn't it? So molarity is weight of the solute divided by molecular weight of the solute into 1000 divided by volume of the solvent in milliliter. Is it clear, students? Now, here you should know the molecular weight of CONO3 twice 6H2O. Okay. Here, the atomic weight of cobalt is found to be 59. Then see, students, here plus this is nitrogen. Nitrogen is 14 plus oxygen is 16 into 3, then into this 2 plus 6 into molecular weight of water is 18. So upon adding all these, how much you will get means this will be 291. This is 291. So this is the molecular mass of hydrated cobalt nitrate. Clear, students? Therefore, molarity is equal to, how much weight is given here? 30 gram. 30 gram is given. 30 gram of this substance is given. Divided by its molecular mass is 291 into 1000. Divided by, what is the volume of this solution? That is 4.3 liter is there. 4.3 liter is a liter. Is that it? So if it is liter, it is not necessary to take this. Otherwise, you have to multiply by 1000. Those two will get cancelled. That means we can write it as 30 divided by 291 into 4.3. This will give you. See here, this is 291 into 4.3. This is 30 divided by, this value is 1251.3, and this will be 30 divided by 1251.3, and this will be 0.0239 is there. We can take it as 0.024 moles. That M stands for, this M stands for moles per liter, which is molarity. So A answer is this. Let's go for B one. B. See, students here. B is it can be calculated here in two different manner. Calculate the molarity of 30 ml of 0.5 molar solution diluted to 500 ml. So what we do is we go in two different manner. Then we'll decide which one is easy for us. Okay, let's go for it. First method. Okay. Here, say to calculate the molarity, we need the weight, isn't it? Weight. So we need to find out what is the weight of sulfuric acid present in 30 ml of 0.5 m solution. See, students. 1 liter of 0.5 m H2SO4 contains 49 gram of H2SO4. So how we have calculated? Look at this one. So molarity is equal to weight of sulfuric acid divided by molecular weight of sulfuric acid, which we can write it as 98 into 1000 divided by volume in say ml. Here 1 liter is there. That means this is not necessary to take. Molarity is given 0.5. Weight is to be calculated divided by molecular weight is how much? 98. This implies that weight is equal to 0.5, that's half into 98, which is 49 grams. So it means that 1 liter of 0.5 molar solution contains 49 grams of H2SO4. See students, this implies that 1 liter of or you can say 1000 ml of 0.5 m H2SO4 contains 49 grams of H2SO4, isn't it? Now we want how much is H2SO4 present in 30 ml. So 1000 ml contains 49 grams whose molarity is 0.5 m. So in this case molarity remains same and we want how much gram present in 30 ml. See students. So upon cross multiplication what we get? X is equal to 49 into 30 divided by 1000. See students, this will get cancelled. Then this will be 0.3 and this will be 4.9. This means that 4.9 into 0.3. This is equal to 3927. Then 3 4 is 12. 12 and 4. This is 14. And decimal is 1.47 gram. See students, 1.47 gram of sulfuric acid is present in 30 ml of H2SO4. Now you have to find out the molarity. Say what is the weight of sulfuric acid now? Which is 1.47 gram. Your molecular weight is 98 into what is the volume given? 500 ml. That is 1000 by 500 ml. This will be equal to, see students, this is 2. That is 1492. That is 2.94 divided by 98. This will be 2.94 divided by 98. This is 0.03 molar. Is that clear? Okay, what we have done here in the first method, we have found out weight of sulfuric acid present in how much? 30 ml. This is the weight of sulfuric acid present in 30 ml. Then it is diluted to 500 ml. So then molarity is 0.03. What is happening? Molarity changing from 0.5 to 0.03. That means upon dilution, molarity will decrease. Clear students? Okay, now we will go for the second method, which is very much easy. Second method. Say N1 V1 is equal to N2 V2. This is known. This is from first PUC concept. Some basic principles. That is from volumetry. See students. This is, say 1 is given. This is 0.5 molar given and its volume is 30 ml. Then molarity is asked when its volume is changed to 500 ml. That means molarity is equal to 0.5 into 30 divided by 500. See students, how much we will get? This and this get cancels. This and this will be there, and this will be 10. Okay, something went wrong here. See students, this is 0.5 and molarity is 30 ml. This is M2, that is we need to calculate when it is 500 ml. Okay. This and this get cancels, isn't it? And this, okay, let's see. This is 1.5 is equal to M2 into 50. Therefore, if you remove this, it will be 0.15 is equal to M2 into 5. And if you divide this, it will be 0.053 is 15. 3. Okay. This implies molarity is 0.03. See student, both answers are same. So better you know this, but use it. You should know it and you should use it. Yes, students. If you know this, your basics are very high. Very high. Yes, students, if you know this. And don't use this. You use this. Clear? Okay. Let's go for the next problem. Okay. The next problem is 2.4. Here, calculate the mass of urea. Urea is NH2CO NH2. Calculate the mass of urea required in making 2.5 kg of 0.25 molal aqueous solution. Let us explore this. Here, look at this. Molar, that means molarity is asked. We know that molarity is weight of the solute divided by molecular weight of the solute, that is 2 into. See here, it is given as kg. It means that we should use weight of solvent in kg. If it is in kg, numerator will have just 1. And if it is in milligram, it will have 1000. Yes, students? Okay. Now, check mass of urea. We need molecular mass of urea. See here, molecular mass of urea is equal to, as it is NH2CO NH2. See students, it is 14 plus 1 into 2 plus 1 into 12 plus 1 into 16 plus 14 into 1 plus 1 into 2. If you add all these, you will get 60. Okay? So we have got this. So this is asked, calculated mass. Next, required in making 2.5 kg. This is given. This is given. That means molarity is equal to weight, that is X. How much molarity we want? See students. Molarity is how much? 0.25 molar we want. This is equal to. That weight is to be calculated. Divided by molecular weight of urea is 60 into 1 divided by, what is the weight of solvent? That is 2.5 kg. That means X will be equal to 0.25 into 2.5 into 60. Okay. Now, upon multiplying this, how much we will get is 20. This will be 625. 1, 2, 0.625. 25 is 625. Decimal will be after 3 digits. 1, 2, 3. 3 digits into 60. Okay. Now it is 6 3s are C. If you remove this, it will be here. This decimal will be here. Now 6 5 is 30. 3, 12, 15, then 36, 37. Decimal will be here. Okay. It means that 37.5 gram of urea is required to prepare 0.25 molar of 2.5 kg solution. Clear, students? Okay. Next, let's go for another problem. Here, this has got three other problems. Let us clean the board first. Okay. What it says is 2.5. Exercise 2.5. Calculate A. Molality. B. Molarity. C. Mole fraction of Ki if the density of 20% mass by mass aqueous Ki solution is 1.202 gram per ml. Okay, students. Here, what is given is 20% mass by mass aqueous solution of Ki is given, whose density is 1.202 gram per ml. Then, based on this, what is asked is calculate molality, and mole fraction. See, students, let's go by one. Let's go for first one. Let's go for A. This is molality. Okay. Molality is M. This is equal to weight of the solute divided by molecular weight of the solute into. See here, it is in ml. That means 1000 divided by weight of solvent in gram. Now check what is given. What is given here? 20% mass by mass is given. Okay. 20% mass by mass aqueous solution is given. It means that, see here, this means that 20% weight by weight aqueous solution. This means that 20 gram of Ki is in 80 gram of H2. Yes, students. 20 gram of Ki is in 80 gram of water, which means 20% mass by mass. Now we have this weight. So molecular mass of Ki, it will be how much molecular mass of Ki? Potassium is 39, and iodine is, say potassium is 39, iodine is 126.9, which is 127. We can take it as 127. So it will be, see here, 16, then 6, 166. Molecular mass of Ki will be 166. Okay. Now we have this, and here weight of solvent. How much is given? Its weight of solvent is not given here. What to do? So molarity is equal to weight is how much? 20 gram. So weight of solvent is given as, see, weight of solvent is given as 80 gram. So W2, that is 20 gram divided by molecular mass of Ki, which is 166 into 1000 divided by weight of solvent is 80 gram, and this will be equal to, see here, let's calculate it. This and this get cancels, then these two zeros will make decimal over here, then it means that 20 divided by 1.66 into 8. Okay. 1.66 into 8 is 20 divided by 13.28. So it will be 20 divided by 13.28. 20 divided by 13.28, which is 1.506 molar. So its molarity is 1.506. Okay, this is done. Now let's go for second one, B, which is molarity. Molarity. Here W2 divided by molecular mass of solute into 1000. Here volume of solution in ml. See students. Here density is given, by which you will have to calculate the volume. See here, 1.202 is the weight of 1 ml. 1.202 gram is weight of 1 ml. That means 80 gram weighs how much? Volume. So X is equal to 80 gram into 1 ml divided by 1.202 gram. So gram get cancelled, so you will get answer in terms of ml. That means 80 divided by 1.202. This will be 66.55 milliliter. See students, for the calculation of molarity, we have used directly weight of the solvent. Now the weight of the solvent should be converted into this. Okay students, 66.55 ml weighs 80 gram. Clear? If density, use this volume for the calculation of molarity. Therefore, molarity is equal to, weight is 20 gram, molecular mass is 166 into 1000 divided by 66.55. Well, this will be equal to, see students, these three zeros get cancelled if you place this decimal over here, and this will get cancelled if the decimal shifts over here. It will be here. That means 2 divided by 0.166 into 6.655. This will be equal to 0.166 into 6.655. This will be 2 divided by 1.10473, and molarity hence will be 2 divided by 1.10473. This will be 1.810. This is molarity. Okay. Now let's go for the third one. C, that is mole fraction. Mole fraction of Ki is equal to number of mole of Ki divided by number of mole of Ki plus number of mole of water here. See here students. Number of mole of Ki is equal to weight of Ki, which is 20 gram, molecular mass is 166. This will be 20 divided by 166, which is equal to 0.120 is there. Now, number of mole of water is equal to, weight of what is known as 80. We got it as 80. Divided by molecular mass is 18. This will be 80 divided by 18, and this will be 4.44. Therefore, mole fraction of Ki will be number of mole of Ki, which is 0.12 divided by Ki 0.12 plus water, which is 4.44. This is equal to 0.12 divided by, this is 5.4. This is 4.56. That means it is 0.12 divided by 4. 0.12 divided by 4.56. This will be equal to 0.0263. Well, this is the mole fraction of Ki. So mole fraction of Ki is unitless. It it is its molarity, and it is its molality. So students, molarity is how much? 1.506 mole per kg. Molarity is 1.81 mole per liter, and mole fraction is 0.0263. Okay, students, these are some of the problems which are present in the textbook, that is in text problems. Suppose you have any other problems, just WhatsApp me and try to solve them. Is it clear? Hello students, in the last discussion we have studied the meaning of solution, different types of solution, then different ways of expressing the strength of the solution, etc. In this class we study the meaning of solubility and the factors which affect the solubility of this solute in the solution or in the solvent. See students, so today's topic is solubility. We'll do an experiment and try to understand the solubility, students. See here. We take, say, 100 ml of water, then some, say, enough quantity of sugar, and we maintain temperature constant and pressure is also constant. Well, these are the experimental conditions. Now what we do is, we place 100 ml of water in the container. Now this is 100 ml water at the given temperatures, T and T is constant and pressure is also constant. Now what we do is, we add sugar into it. How do we add it now? Say we take 1 teaspoon of sugar, then add into this. What happens? Upon stirring, sugar dissolves. That means sugar is solid. This is added into water, which is liquid. Then what is happening? Upon stirring, it is dissolving. Means it is mixing up with the water. That process is called as dissolution. That means we are getting solution of sugar. We are getting it. Okay. Here what is happening is, this sugar is breaking into very small particles which we are not able to see. Well, this process of getting solution, this process is getting solution of sugar, is called as dissolution of sugar. That means sugar dissolves it, rather disappears upon putting it into water. Now upon, see here students, when sugar dissolves into particles, then in this solution what we notice is, some of the particles will collide with each other. Dissolved sugar particles will collide among themselves and they'll become larger one. Once they become larger, then due to action of gravity which acts upon it, they settle down. That means these particles will settle down. This is called as precipitate, or this is properly called as, in this case it is properly called as crystallization. See students, this is another term. See, crystallization means, here what is happening? Solid is separated. That means came out, separated out of solution. See students, solid is dissolved, is dissolution. Now we have got sugar solution. From the sugar solution, sugar is precipitated. Sugar is precipitated. It means solution is solvent is separated. It means exactly what is happening is, see here, solution of sugar, from the solution of sugar, sugar is separated. That means sugar is obtained back. That means this is solute is separated. This process is called as crystallization. Now we can write like this, isn't it? This implies that dissolution and crystallization, they are opposite of each other. They are opposite. Are you getting this? What is the opposite of dissolution means? You can call it as crystallization or you can call it as even precipitation. Is it clear, students? How does that precipitation takes place? Due to the collision of these dissolved solute, crystallization or precipitation takes place. Now see, students, here one is speed of dissolution is there. Another one is speed of crystallization is there. That means initially speed of dissolution is more than the crystallization speed, and a stage will reach. Let me repeat it. Initially, when we dissolve sugar into water, dissolution speed is more than the crystallization speed. Then, due to continuation of the process, slowly dissolution speed decreases and crystallization speed increases. That means what is happening here? Initially, this is large. It is little. Due to progress of the process, what is happening? It will decrease. It will increase, and a stage will reach where a rate of dissolution becomes equal to rate of crystallization. This situation is called as saturated or saturation. Saturation means, students, here, saturation means ability to dissolve, ability of solvent to dissolve solute is completed. Ability of saturation means ability of this solvent to dissolve solute is over at the particular temperature and pressure conditions. Is it clear? Then the solution obtained is called as saturated solution. Upon reaching saturation stage, no matter you may add some quantity of sugar, but even a crystal of sugar cannot be dissolved upon reaching the saturation stage as long as temperature and pressure remain constant. That means after that you remove, you filter it. The filtrate obtained is called as saturated solution of sugar. Is it clear, students? How you have got saturated solution? You have taken some quantity of water, to that you have added some quantity of sugar, stirred it, dissolved. This step is repeated till further quantity of sugar upon adding and stirring vigorously will never dissolve. Then you have filtered this, then the filtrate obtained is called as saturated solution. Now in the saturated solution, that means you have got here 100 ml water, into that you have added x gram of sugar. Then little extra, this is little extra of sugar will not dissolve. It means that 100 ml water can dissolve x gram of sugar only. That means its solubility is x gram. Now let us define solubility. Now, is that before defining this, is that clear, students? You have got unspecified quantity of solvent. To that you have dissolved maximum quantity of solute. that maximum quantity of solute that can this quantity of solute dissolve is its solubility. Is it clear, students? Therefore, solubility is nothing but the maximum quantity of a solute that can be dissolved in a particular quantity. This quantity can be volume of a suitable solvent at constant temperature and constant pressure. This is known as solubility. So solubility is the maximum quantity of this solute in a fixed quantity of solvent that can be dissolved at a given temperature and pressure conditions. Clear, students? Okay. What do you mean by saturated solution? Saturated solution is that solution into which extra quantity of solute cannot be dissolved at that particular temperature. Is it clear? Then, what is crystallization? It is the separating out of the solute from the solution. Is it clear, students? Crystallization means separating out the solute particles from the solution. Clear? Okay. What do you mean by dissolution? Dissolution is nothing but the process of making this solute dissolve in the solvent. Clear? Okay. Now what others we can define? See here. Here we can define one is solubility. Second, crystallization. Third, what is that? Dissolution. And fourth, saturated solution. Fifth one. Okay, so listen to this. This can be a very good question. At which stage of the dissolution, maximum quantity of this solute is found? I repeat, at which stage of the solution, maximum quantity of the solute at a given temperature and pressure is found? Answer is at the saturated stage. That means based on this we can have maximum quantity of solute. Well, these are the 5 questions that we can answer here. Clear? Okay, students. One thing that you're supposed to understand is this. Dissolution of any solute in any solvent, suitable solvent, is either associated with a release of energy, that is, the process can be exothermic, or absorption of energy, that is, it can be endothermic. This you need to remember. Now, if you remember this, we can speak about the factors which affect the solubility of this solute in the solution. Clear? Okay. Now what we'll do is, we shall discuss the effect of these parameters on the dissolution process. But before that, what we can understand is, see students, there is no universal solvent. That means, yeah, one exception is there. Water can be regarded as a universal solvent. It's not because everything dissolves in it. Is it clear, students? Water can be regarded as universal solvent. It's not because everything dissolves into it. There are so many substances which do not dissolve in water. Therefore, water is called as universal solvent not because everything dissolves in it, every solid dissolves in it, but water can dissolve maximum number of solutes into it. Whether it is ionic or non-ionic, maximum quantity of solute water can dissolve. Because of this nature, water is regarded as universal solvent. The question is why water has got this ability. It is because of its dielectric nature, dipolar nature. one, and second one is its ability to establish hydrogen bonding with solute. Dipolar nature or dipole moment of water is highest. This is capable of splitting or dissociating any solute that is added to maximum solute that is added into water, and thereby makes solute to dissolving. And the other one is its ability to establish hydrogen bonding. That is also one of the prime reason to make any non-ionic solid to get into solution with water. So because of this, water is regarded as universal solvent. But there are certain substances which are not getting into solution, which do not dissolve in water. We notice that sodium chloride dissolves very easily in water. Chlorobenzene, benzoic acid, etc. they hardly dissolve in water, in normal water. So based on this, say another example, naphthalene, anthracene, they do not dissolve in water at all. So based on this, what we can conclude is polar solvents dissolve polar solutes, non-polar solvents dissolve non-polar solutes. It also means that like dissolves like. Is it clear, students? That means polar solvents dissolve polar solutes. Like sodium chloride dissolves in water. Sodium chloride is ionic, that is polar. Water is also polar. That means like dissolves in like. Whereas carbon tetrachloride, CCl4, non-polar, into that benzene can dissolve. That means that's also non-polar. It means like dissolves like. Is that clear, students? But now what we do is we discuss the effect of these parameters. That means change in temperature and change in pressure on the solubility of solid solute in liquid solvent. It is solid in liquid or gas solute in liquid solvent. That is gas in liquid. That means we shall see now the effect of change in temperature and pressure on the solubility of solid in liquid or gas in liquid. Yes, students? Let's see. Okay, now we shall see the effect of temperature and pressure over the dissolution of solid in solution. Okay. Effect of temperature. This is on dissolution of solid in liquid. See, students, there are certain solids which upon dissolving in water or solvent, they release energy. And there are certain solids upon dissolving in water, they absorb energy. So we can have exothermically soluble salts and endothermically soluble salts. So effect of temperature on both of them is quite different. Let us see this. Suppose we take case 1, where salt dissolves with release of heat. Such salts are called as exothermically soluble salts. See, students, we notice that solute upon dissolving in solvent, this gives solution, and in forming solution, what we notice is, see, students, it is releasing heat. That means we can write it as plus heat. Plus heat. It means that this solute, say we label it, solute A is releasing energy upon dissolving. That means it is exothermically soluble solute. That means if you supply heat energy, for this system, that means you have taken water, say solvent, and into this you have added heat. Then what is here? Here heat is given out. Heat is given out by the system. Heat is given out by the system. Now what you are doing? You are supplying heat energy. You are supplying heat energy. You are heating it. It means that you are, by the supply of energy, you are opposing this process of release of energy. Is it clear, students? System is giving energy. And what you are doing? You are also giving energy. It means your act is opposing the solutions act, isn't it? It means solubility of such salts will decrease. Solubility of such salts will decrease upon increasing the temperature. It means that in such cases, solubility is inversely proportional to temperature. Is that clear, students? Remember, let me repeat this. Solute A, upon dissolving in solvent, it dissolves by the release of energy. And what you are doing? You are increasing the temperature. You are supplying a heat energy for this system. That means this heat energy supplied by you is opposing this heat energy. Clear, students? That means this heat opposes this solubility. And this is in accordance with the famous principle of chemical equilibrium chapter, which is known as Le Chatelier's principle. This is in accordance with the Le Chatelier's principle. We shall see in detail regarding this in that chapter. Okay. You remember this? If solubility of the salt is inversely proportional to temperature, it means that the solute is exothermically soluble solid. Now we take another example here. We take solute B. Upon putting it into solvent, what we notice is solution is produced along with the absorption of energy or heat. This means that this is endothermically soluble salt. Now here what is happening, students? Here solute B is taken into solvent. Now what is happening? Instead of releasing heat energy, it is taking out heat energy. That means it is in need of energy. Now you increase the temperature. What happens? Dissolution process absorbs energy. Now what you are doing? You are supplying energy. It means that the energy supplied by you is helping this solute to dissolve very easily. Is that clear, students? Therefore, what we can write is solubility is directly proportional to temperature. See, students, here. Solubility inversely proportional to temperature. Solubility directly proportional to temperature. Both are correct. But the thing is, this holds good. Inversely proportional to temperature holds good for exothermically soluble salts. Directly proportional to temperature holds good for endothermically soluble salts. Clear? Okay. Now, what we do is we try to represent. We do one exercise here. There is a graph. See, students. There is a graph of temperature and solubility. One is this. This is solute A. And another one is this. Solute B. See, students. This is solubility of A and B. This is versus temperature. Now what do you notice here? Solubility of A is, what is happening? Decreasing with rise in temperature. Solubility of A is decreasing with increase in temperature. Isn't it? Decreasing with increase in temperature. Solubility decreases with increase in temperature. That means this is inversely proportional. Isn't it? That means it is exothermically soluble salt. Now here, if you increase temperature, what is happening to solubility? Solubility was here this much at this particular temperature. Now it is increasing. It is becoming this much. So with rise in temperature, what is happening? Solubility increases. It means that it is endothermically soluble salt. Yes, students? Many times such examples have come in the examination. Be careful. Okay. Now this is the effect of temperature. Now this is the effect of increase in temperature. This is the effect of increase in temperature. Now what to do is, if you decrease the temperature, what happens? See students, if you decrease the temperature, solubility will increase. Where? Exothermically soluble salts. And in this case, if you decrease the temperature, what happens? Solubility will also decrease. Therefore, this is the effect of temperature on the solubility of the salt, solid salt. See students, there is no effect of changes in pressure over the solubility of solid in solution, because solids and liquids are almost incompressible. Hence, there is no effect of change in pressure on the solubility of the solids and liquids. Remember this. There is no effect of change in pressure on the solubility of solid or liquid in solvent. Reason for this is solids and liquids are almost incompressible. See students, why effect of change in pressure does not affect the solubility of a solid or a liquid in solvent means solids and liquids are mostly incompressible. Because of incompressibility nature, there is no effect of change in pressure on the solubility of the solid in liquid or liquid in liquid. Clear students? Now we shall see the solubility of gas in liquid. Okay. Hello students. Just look at these situations. These are some questions which we can answer out of the discussion of one article in this video. Clear? Now look at this question. This question says, aquatic species are more comfortable in cold condition rather than warm condition. Let us see why. Second question is, the bottles of soft drink, that is soda water, are packed under high pressure conditions. Why is it so? Then third question is, at high altitudes, climbers face a medical condition where they will not be able to think properly, and that medical condition is called as anoxia. And the fourth question is, the deep sea explorers use one instrument container on their back. That container is called as scuba. That is, scuba is underwater breathing apparatus. Scuba stands for underwater breathing apparatus. And the person who uses that apparatus and dives into the sea, they are called as scuba divers. Clear students? Okay. Scuba divers face another medical condition, which is a painful condition known as bends. All these questions we can answer by referring to one article, that is solubility of the gas in liquid. Let us see this. Article is solubility of a gas in liquid. Very, very important article. Let us see this. Solubility stands for maximum quantity of the gas that can be dissolved in a fixed quantity of solvent. Here solvent is usually water. That means quantity of water is fixed. Into that fixed quantity of water, how much quantity of gas maximum can be dissolved? That maximum quantity is called as solubility. Is it clear? That we have seen in the past video. Now what we do is we conduct an experiment here. Let there be a container containing some quantity of water. Then over this, let us assume that there is a gas. So these are gas molecules. Now we have a container containing liquid, and above this gas is present. Some gas is present. Now as long as this mouth of the container is kept open, it means that that gas is experiencing atmospheric pressure. So this is under atmospheric pressure condition. Clear, students? In this situation, some of the gas molecules will strike the surface of the liquid and try to get into solution. Gas molecules getting into solution. Clear, students? Some of the gas molecules will strike the surface of the liquid and try to enter. This process is called as dissolution of gas in water. Dissolution of gas in water or in any particular solvent. Okay. Here, gas molecules will have independent existence, but once they get into solution, they will not have independent existence. They undergo condensation, gas state to liquid state. Therefore, this dissolution of gas, the dissolution of gas is nothing but condensation of gas. Condensation of gas is exothermic. Because, see students, because why this is exothermic means because gas is converted into liquid. This is possible only when you remove the gas, heat from the gas. That is exothermic. Or if you have any confusion here, go from liquid to gas. How can you convert liquid into gas? By heating. That means this is endothermic, but this is exothermic. Clear? Therefore, we can say that dissolution of gas in a liquid or a solvent is an exothermic process. Is that clear, students? Now, suppose we want to increase the dissolution of gas into water. How can we do it? See, students, surrounding temperature and pressure are constant. Then what we do is we apply pressure on this. How to apply pressure on this gas? We use a piston. Then we increase pressure by putting weight or pressing it. Then what we notice, due to this increased pressure, what we notice is more gas molecules will enter into the solution. So here more gas molecule will enter into solution. So this implies that if you increase pressure, solubility of the gas is also increasing. So it means that pressure is directly proportional to solubility. Is it clear, students? But temperature and pressure are kept constant. These are surrounding conditions, surroundings. So if you increase pressure, solubility is also increasing. Clear? Okay. Now this solubility can be considered as, say, mole fraction. That is X. So it means that pressure of the gas above the liquid is directly proportional to mole fraction of the gas in the solution. Is it clear, students? This is the pressure is above, mole fraction is in liquid. That means pressure of the gas above the liquid is directly proportional to mole fraction of the gas in the liquid. That means mole fraction is solubility. Remember this. Is that clear? Now what we do is, say we take here mixture of gases. Different gases have different solubilities. So in this case, if you increase pressure, both the gas will try to get into solution. Now, in this case, here we have two types of gases. That means their solubility must be considered in terms of mole fractions. To consider their solubility in terms of mole fraction, we'll have to use partial pressures. It means that mole fraction of a gas in the solution is directly proportional to its pressure over the liquid. Its pressure over the liquid means partial pressure, its own pressure. That means in the mixture of gases, solubility of the gas or mole fraction of the gas in the solution is proportional to proportional to what? Partial pressure of the gas above the liquid. Is it clear, students? Now, here, this can be written as pressure is equal to kH into mole fraction. Well, this concept is given by, this equation is given by Henry. Therefore, it is called as his law. And this kH is called as Henry's law constant. See, students, here. According to him, not according to him, the most commonly used statement of Henry's law is this. Mole fraction of the gas in the solution is directly proportional to partial pressure of that gas above the solution. This is the most used definition of Henry's law. Now, Henry's law deals with solubility also in this manner. See, students, here kH is equal to P by X. Here X is solubility. Then at constant pressure, kH is found inversely proportional to solubility. Remember this, students. So at the constant pressure of the gas, solubility is inversely proportional to kH. It means that kH, if it is more, solubility will be less. Let us take some examples here. Suppose A2, B2 and C2. They are the different gases and whose kH values are, let there be 0.1, 0.5 and 0.7. Let's say any values. Then what we notice? Which among these gas dissolves very quickly in large quantity? See, students, as we know that solubility is inversely proportional to kH. It means that kH, if it is small, solubility of that particular gas will be easier and more. See, students, A2 has kH value least amongst these. That means its solubility will be highest. And C2 has highest kH value. That means its solubility will be least. Therefore, order of solubility, ascending order of solubility or descending order of solubility. See, A2 is more than, B2 is more than C2. Is it clear, students? That means Henry's law constant help us to understand the solubility quantity of gas that dissolves in. kH value, if it is more, solubility will be less. Now, just look at this. From this, we can draw a graph. See here, this, if you consider this as one variable which is y, this is another variable which is x, this will be a slope. That means y is equal to mx. It is. If y is equal to mx, the nature of graph will be this. If it is the say pressure, this is the mole fraction, or reverse also. This will be kH value at a particular temperature and pressure condition. It means that if you increase pressure, mole fraction is also increasing. Or you can write it as, instead of P here, you can take X. Instead of X here you can take P. This remains same. If you increase pressure, mole fraction is also increasing. It means that increase of pressure increases the solubility. Okay. Now, by using this law, we can try to answer these questions. See here, if you increase pressure, then solubility increases. In addition to the increase in pressure, if you decrease temperature, then also solubility increases. So, increase in pressure and decrease in temperature increases the solubility. Remember this, students. What is this? Temperature should be decreased and pressure of the gas above the liquid should be increased. This combined effect of these two will be greatly increasing the solubility of the gas. That is mole fraction of the gas into the liquid. Now, we notice that dissolution is an exothermic process, isn't it? It means that while dissolving the gas into water, heat energy releases. Clear? Now, what we do is we increase the temperature of the gas. Here, we increase the temperature of the system. We heat it. Due to this, what happens? We know that as the dissolution is exothermic, means while dissolving, system releases energy, and you are supplying energy. It means that you are opposing the system's process. Is that clear, students? System is releasing energy and you are supplying energy. It means that your act is opposing the system's process. It means that dissolution decreases if you increase the temperature of the system. Is it clear, students? Now, look at this aquatic species, that is marine life. They feel more comfortable in cold condition because in cold condition, dissolved oxygen is more. That means they can breathe very easily. Clear, students? And if you heat the system, that means if the aquatic life is at warmer condition or at higher temperature, dissolved oxygen will be reduced. Is it clear, students? Quantity of oxygen dissolved is reduced, and the reduced availability of oxygen, aquatic life cannot be comfortable. Is it clear, students? Therefore, aquatic life is more comfortable in cold water because of the availability of more quantity of dissolved oxygen, and at higher temperature the dissolved quantity of oxygen will be decreasing. Next, see, students, cold drink or soda water bottle, if you open it, it will fizz out, froth will come. Let the froth be settled, then it means that dissolved carbon dioxide will come out. Why it will come out? Atmospheric pressure is lesser than the pressure of the gas inside the soda, that is liquid. So once you open the bottle, what happens? Carbon dioxide gas will come out. Now, once the carbon dioxide gas comes out, you taste that liquid. It is tasteless. It will be tasteless. You cannot drink it out. It means that the taste of a cold drink or soda water is because of the presence of carbon dioxide in it. Is that clear, students? Carbon dioxide literally stands for carbonic acid, H2CO3. Now, more quantity of carbon dioxide means more taste. It means that carbon dioxide gas cannot dissolve easily. You have to make it to dissolve by applying pressure over it. That's why bottles of soft drink or soda water, they are packed under high pressure because high pressure enhances or increases the dissolution of carbon dioxide in it. Is that clear, students? Okay. Now, at high altitude, what happens? When you go above the height, or at higher altitudes of say hill, then what we notice is surrounding air density will decrease. When surrounding air density decreases, what happens? We feel shortage of air or oxygen for breathing process. Once a person feels shortage of oxygen, then he will not be able to think properly. This medical condition is called as anoxia. Is that clear, students? So as we climb the height at higher altitudes of a hill, then what we notice is a person will feel anoxia. That anoxia stands for availability of less quantity of oxygen. Is that clear? Then scuba divers. Okay, students. Let us look at the last question. Scuba divers experiences a painful sensation when they come out of sea. That painful sensation faced by scuba divers is known as bends. B-E-N-D-S. So what is bends? It is the painful sensation felt by or experienced by scuba divers when they come out of sea. Okay, let us look at this. Scuba stands for scuba. Scuba stands for underwater breathing apparatus. So scuba stands for underwater breathing apparatus. See students, in olden days, sea explorers, that means deep sea divers, what they used to do is they used to carry an oxygen cylinder, that is air cylinder on their back. That was having air, that is mixture of nitrogen and oxygen along with some other gases. And nitrogen quantity is found to be very much larger, that is around 78% by volume. And once they enter into the deep of the sea, surrounding pressure because of the sea will be very much increased. It will increase a lot. At this higher pressure, due to surrounding, some quantity of nitrogen that they breathe in the form of air found dissolving in their blood. That means when they start breathing the air of the oxygen cylinder, then some quantity of nitrogen dissolves into blood because of high pressure of the surrounding. So no problem till divers are as long as they are in sea. Then once they come out of the sea, their body get exposed to low pressure because of atmosphere. Due to this low pressure, what we notice? If you decrease the pressure, what happens? Solubility will decrease. That means the dissolved nitrogen will try to come out. During this, it forms bubbles. This bubble will block the veins, and this situation makes them feel very heavy pain. It is like a medical emergency. So this painful sensation is due to the nitrogen's escape out of the blood. Is it clear, students? Therefore, this pain, this medical condition that the scuba divers face, that's called as bends. Is it clear, students? When the pressure decreases, solubility of the gas in the solution also decreases. Is that clear? Nowadays, the scuba will contain, see students, helium 11.7 and nitrogen 56. It was earlier 78% by volume. Now it is reduced. So the part place of nitrogen is taken by helium. That means helium is used as a diluting agent. Presence of helium will avoid bends. Is it clear, students? Okay. So here we have answered all the questions, isn't it?